we are discussing about different data link layer protocols. We already discussed in data link layer, data will be transmitting in the form of the frames. Previously, we discussed about CSMA by CD protocol. It will detect the collision. But when it will detect the collision, once the receiver receives the data, if the receiver receives only one data that is sent by the source station, then there is no collision. If the receiver receives two signals, here I have to carefully say they are two frames. If the receiver is receiving two informations, one is source information and the second one is collision information, then only it can say collision occurred. So only after the reception only we can detect the collision. But here we are discussing about the new protocol without occurring the collision. Before the collision has to occur, we are trying to avoid that collision. That's why this is carrier sense multiple axis collision avoidance. In the previous protocol, after the collision occurred, we detected. In this protocol, we are trying to make sure that there is no collision occurrence in the channel. That's why we are calling this as a collision avoidance. Here, from the station, we want to send a data to the destination. That data is nothing but a frame. The station is ready to transmit the frame. The frame length may be large or frame length may be less, that we are not discussing. Even though the frame length is large, this protocol is capable of sending that frame. That we will discuss. Here station is ready to transmit. When the station is ready to transmit, we are checking whether the channel is ideal or not. Is there any data in the channel? Are there any frames already in the channel? We are checking. If there are no frames, if there is no data in the channel, we are not immediately sending the data. Why? To avoid the collision. Because remaining stations may also think that because the data channel is ideal, we can send the data. That's what the problem we have seen previously. Now, when the station wants to send the data, the channel is ideal, but still we are asking the station to wait for some amount of time. That is what we are calling as inter-frame space. Station, channel is ideal, but you have to wait for some amount of time. After that some amount of time, again we are checking, there is no information in the channel, there is no data in the channel, you can send the channel now. You can send the information in the channel now. That's how we are making sure that at a time, one station can send and one station can receive. Here you can see, in the flowchart we have given, when the station is ready to transmit, we are checking is the channel is ideal or not. If the channel is not ideal, definitely it will again go to this loop, again it will check whether channel is ideal or not. It will go on checking. Once the channel becomes ideal, then we are not directly sending the data. We are sending to the access point, the source is sending, I am ready to send. Because the channel is ideal, give me access to me, I will send. Then access point is saying, okay, wait for some amount of time. That is what we are calling as inter-frame space. After waiting some amount of time, we are checking the channel again. There is no data. Then we are sending, you are clear to send the signal. When the clear to send signal came, the station is transmitting the information in the form of the frames. We are sending the information in the form of the frames. So that frames data will be transmitting in throughout the channel. Okay, this is how the transmission will happen from one source to one receiver. There is only one communication. It is a half duplex communication. At a time, only one station can send, only one station can receive at a time. That's why this communication we are calling as a half duplex communication. At a time, one device sends and one receiver receives. Mainly it is used in wireless LAN. For wireless connection, this is an excellent data link layer protocol. According to IEEE 802.11 standards, this protocol, excellent service will be provided without occurrence of the collision. We can transmit the data from the source to a receiver. If there is no traffic, we are not sending the signal, we are waiting for some amount of time. We are calling that as a interframe space. If after the interframe space we are sending the data, then we are waiting for the acknowledgement. After the receiver received the data, source has to know receiver already received the data. We have to receive an acknowledgement. If the acknowledgement is not sent in the given amount of time, then the source may think that data is lost. It will again start sending the same amount of the information. So this is how CSMA CA, Carrier Sense Multiple Access Collision Avoidance Protocol, will work. Now tell me, here in the CSMA CA, we are trying to avoid the collision or we are trying to detect the collision? Avoid the collision. How we are trying to avoid the collision? We are not at all giving, when all stations are ready to send the data, we are not at all giving permission to all stations. We are giving permission to one station. When that station is saying, I am ready to send the data, we are saying, okay, we will check. We will check the channel by using the interframe space time. Still after checking also it is ideal. Then ready to send signal when the source sends. Immediately after that you can clear to send. You can send the signal. Then the frames we are sending. Once the frames are received, then acknowledgement should be sent saying that I have received the frames. Then only that the access will be given to the second station to send the data. That's why there is no chance of the collision. It is a best suited protocol for the wireless networks. So these are the advantages. As just now we have discussed, this is best suited protocol for the wireless networks. There is no unnecessary traffic. The signals are very clear. Because we are using the signals are ready to send and clear to send, we are sending acknowledgement. There is no unnecessary traffic from the second channel. Second station, sometimes I repeated channel. Only channel means the medium which we are using to transmit the data. Whatever the data that is being sent, that is source. From source only we have to send. Channel is a medium only. Okay. What are the disadvantages? This waiting time is disadvantage. When all are ready to send, when the channel is ideal, still you are saying wait. That is wastage of time. And when all are ready to send, that huge bandwidth is there, but we are saying only one station should send the data in the entire bandwidth. That is also wastage of the bandwidth. And efficiency is getting decreased. When all stations are ready to send the data, but still you are saying stop, single station has to send the data, efficiency is also less. So that's why we use generally this for the wireless networks only. This is what carrier sense multiple access collision avoidance.